So on to problem number 20 of the MIT Integration Big Qualifying Exam 2016. It's actually a very interesting problem from x equals an integration from x equals to 0 to x tending to infinity of 1 over 2 plus the hyperbolic cosine or cos x. So yeah, let's see how we may be able to solve this. So this is our problem, right? Integration from x equals to 0 to x tending to infinity of 1 over 2 plus hyperbolic cosine of x. So hyperbolic cosine cos x is the same as e to the power x plus e to the power negative x over 2, right? Now, which means our problem is 0 to infinity of 2 plus e to the power x plus e to the power negative x over 2, which is the same as 0 to x tending to infinity of 1 over 4 plus e to the power x plus e to the power negative x over 2. And that 2 goes up, and so we have 0 to x tending to infinity of 2 over 4 plus e to the power x plus e to the power negative x. Now, one thing we could do is, we already have our problem as follows. Right? I could also rewrite this as 4 plus e to the power x plus 1 over e to the power x dx, so that, I could summarize it in such a way that this is 4 e to the power x e to the power 2x plus 1, like that. Now, if we have our problem as shown here, e to the power x plus 2 squared is equals to e to the power 2x plus 4 power 2x to the power x plus 1 plus 4, rather. And so this part here is the same as, in other words, for e to the power x plus e to the power 2x is the same as e to the power x plus 2 squared minus 4, right? So I can pull this part here and just plug that in there. So let me box that, right? So we have integral from 0 to infinity, 0 to x tending to infinity of e to the power 2x of ex plus 2 squared minus 4 plus 1 dx. So our problem now becomes integral from x equals to 0 to x tending to infinity of 2 times e to the power x e to the power x plus 2 negative 4 plus 1, this is squared, leaves us with negative 3, right? So it's very important to know, I usually don't like using hyperbolic functions, but this is one thing we need to know. Hyperbolic cosine squared x minus hyperbolic sine or sinh x squared is equals to 1. Divide through by hyperbolic sine squared, we get a hyperbolic cotangent squared x minus 1 equals to the hyperbolic cosecant squared x. So using this identity, we can substitute with cotangent, obviously taking into account this constant here, and be able to obtain a more easy expression of cosecant. So with that in mind, we can say let e to the power x plus 2 be equal to square root of 3. I have put square root of 3 here so that when I square it becomes 3 and I'm able to pull the 3 out. So square root of 3 cotangent, hyperbolic cotangent of y. So that ex dy dx, dx dy, you know, some things just become ingrained. So it is dx dy equals to negative 3. That again is not right. The derivative of hyperbolic cotangent is negative hyperbolic cosecant squared y. And so what we end up getting is ex dx can be substituted off with negative square root of 3 hyperbolic cosecant squared y dy. Important. Now let's look at the limits, right? So we are moving from the x to the y. And mark you, we said ex plus 2 equals to root 3 hyperbolic cotangent y. So when x equals to 0, this means e to the power 0 is 1 plus, so we have 3 over root 3. So we have the inverse or arc hyperbolic cotangent of root 3. And then as x tends to infinity, this entire part tends to infinity. The hyperbolic cotangent, the inverse of the arc, is 0. And you can go ahead and check that. Okay, so our problem that is 0 to infinity x over e to the x plus 2 squared minus 3 becomes we have hyperbolic, the arc hyperbolic cotangent of root 3 0, and then we pull 2 out. In place of this part here we have negative root 3 cos x squared y dy, and in the denominator we have 3 hyperbolic cotangent squared y minus 3. We can pull the 3 out in the denominator so that we have 2 over 3 hyperbolic cotangent 0, and here we have negative 3 over, we saw hyperbolic cotangent squared of a variable minus 1 is hyperbolic cosecant. So this becomes, this crosses, and so we do have negative 2 root 3 over 3, and we've pulled the root 3 out. Hyperbolic arc hyperbolic cotangent over root 3 0, and since the cosecant squared cancel out, we are left with negative 2 root 3 over 3 y, and then we have arc hyperbolic cotangent 3, and we have 0. So we have 2. Let's just express this as that hyperbolic cotangent of root 3. Now this is our answer, but we can also express it in some other simple format. Let's so we've found that this plus cosh x is equals to 2 root 3 the arc hyperbolic cotangent of 3. Yeah. However, we know cotangent of a function x being equal to e, and this is, let me probably begin from the very elementary parts of it so that we're able to see it, is cosh x over sinh x, which is equals to e to the power x plus e to the power negative x divided by 2 over e to the power x minus e to the power negative x all over 2. So this becomes ex plus e to the power x over ax minus e to the power negative x. But now if cotangent of x is equals to a constant, let's say k, so e to the power x plus e to the power negative x over e to the x minus e to the negative x is equals to k. That means that x is equals to of k, right? So what is x? We can always find it this way, and that is the scenario where we have this root 3. So e to the x plus e to the negative x over ex minus e to the negative x equals to root 3, which means that ex plus e to the negative x is equals to root 3 e to the x minus root 3 e to the negative x. And so we can even go ahead as to say we have e to the x plus 1 over x equals to minus root 3 over x. And so we have e to the 2x plus 1 equals to root 3 e to the 2x minus root 3. And so one thing we can do is we have root 3 plus 1 equals to, okay, and so e to the 2x is equals to root 3 plus 1 over root 3 minus 1, and log of e to the 2x is equals to natural log of root 3 plus 1 over root 3 minus 1. And so 2x natural log of e, this becomes 1, is equals to natural log of root 3 plus 1 over root 3 minus 1. So x is equals to a half of natural logarithm of, we can do this just rationalize the denominator a little bit. So this becomes a half natural logarithm of we have 3 plus 2 root 3 plus 1 over 3 minus 1, which is a half natural logarithm of 4 plus 2 root 3 over 2, 2, 2, 2, 1. So we have x being equal to a half natural logarithm of 2 plus root 3. So our integral was from 0 to infinity of 1 over 2 plus cos x, and we found it to be 2 over root 3 hyperbolic arc hyperbolic cotangent of root 3. And since this is now equal to, let me just delete that a little bit, is equals to a half of natural logarithm of 2 plus root 3. So our answer could also be equal to natural logarithm of 2 plus root 3 all over root 3. So we have two ways of expressing our answers. So yeah, that was pretty much it. Thank you so much for tuning in. Until next time, bye bye.